Oh, I'm so frustrated. Anyways, it's all technical issues, stupid phones. But anyways, I'm not going to go through doing these again because it's like the third time. So I'm just going to walk you through it. So number 19, y equals 2x squared minus 8x plus 9. We're supposed to find the extreme values. So we have no interval to go off of, so it's going off of everything. So we just need to find the critical values. So I had nothing originally in my t-chart because I didn't have anything to go off of. So the only way we could find critical values is to take a derivative of the function and set it equal to 0 and see what we get. So taking the derivative, I get 4x minus 8, set that equal to 0, and solve for x, we get x equals 2. So we only have one critical value, and that's at x equals 2. So I did a little number line graph, and at 2, if I plug in a number smaller than 2, like a 1, I'm going to get 4 minus 8 is a negative 4, so I have a negative. If I plug in a number after 2, like a 3, 4 times 3 is 12, 12 minus 8 is 4, so that's a positive. So since it's going from negative to positive, I have a upward facing little u, and so it's a minimum. So this value is a minimum value. So y then has a local minimum value of 1 at x equals 2. Oh, and instead of plugging it in, you could plug it in to get the 1. So plug in a 2 for x and you get x equals or y equals 1. Or you can use synthetic division. It's a little bit quicker, I think. I don't know about you, but for me it's quicker. And you still get the same answer. Okay. Number 21, I was going through it and then I got cut off. So same type of thing. We have to take a derivative. So the derivative would be 3x squared plus 2x minus 8. The derivative of 5 is 0, so that's why there's nothing else after that. Set it equal to 0, and we get a hard trinomial. So there's two ways to find the critical points. You can use the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So you could use that, or you can factor it and find it that way. Factoring, I think, is quicker than quadratic formula, so I will always go with factoring unless it's something really difficult, and then I'll go to quadratic formula. But this one wasn't bad, so I factored it. It was factorable using product sum, and I got factors of x plus 2 and 3x minus 4. And break those apart, set them each equal to 0. I was in the middle of this before I got cut off. Okay, so here we get x equals negative 2. There's one value that I get to add to my table. And then add the 4 and then divide by 3, and x equals 4/3 is my other critical value. So obviously the negative 2 is smaller, and the 4/3 is bigger because it's positive. Positive number is automatically bigger than a negative number. All right, so let's do a number line graph. Okay, and this is y prime, and I have a negative 2 and a 4/3. So 4/3, remember, is 1 1/3. Okay, so if I pick a number smaller than negative 2, like a negative 3, let's see, if I plug in a negative 3 for, where am I at? Right here in the factors. Negative 3 plus 2 is negative 1, so that's negative. 3 times negative 3 is negative 9. Negative 9 minus 4, that's still negative. Negative times negative is positive, so this could be positive. Okay. And then if I pick a number between negative 2 and 4/3, I could pick like 0. 0 plus 2 is 2. 3 times 0, that's 0 times negative 4. So 2 times negative 4 will be a negative number. If I plug in something bigger than 4/3, like a 2, 2 plus 2 is 4. 3 times 2 is 6. 6 minus 4 is 2. So it will be a positive times positive, which is positive. So this tells me that at negative 2, it's going from positive to negative. So positive to negative means it's got to be facing down. I have a max. From negative to positive means I'm going down and then up, negative slope and then positive slope, so I have a min. So I have a max and a min. Okay, now I got to figure out what those y values are, so it is convenient to use synthetic division to plug them in instead of just plugging it in, but synthetic division is the same thing as plugging it in. I think, in my opinion, it's quicker, but do whatever is quicker for you. I'm going to use synthetic division. So we're plugging in a negative 2. And the coefficients are 1, 1, negative 8, and 5. Bring down the 1 and then multiply. 1 minus 2 is negative 1. Multiply again. Positive 2, negative 6, 12, 17. Okay, so when x is negative 2, y is 17. Now let's do the same thing for the 4/3. 1, 1, negative 8, 5. Okay, bring down the 1. 1 times 4/3 is 4/3. Let's get a common denominator. So 1 is the same as 3/3. 3/3 plus 4/3 is 7/3. 7/3 times 4/3. Let's see, 7 times 4 is 28. 3 times 3 is 9, so 28/9. Let's get a common denominator. So I'm going to need a denominator of 9, which means I need to multiply 8 by 9, which is 72. So that's a negative 72/9 plus 28/9 is a negative 44/9. And then multiply again. Negative 44/9 times 4/3. So negative 44 times 4 ends up being negative 176. 9 times 3 is 27. Need to get a common denominator again. So it has to be a 27, which means I need to multiply 5 times 27, which is 135. So 135/27 minus 176/27 is negative 41/27. Okay. All right. So I have my max and I have my min. Max at negative 2, min at negative 41/27. All right. So for my answer, I'm going to say y has a local max of 17. I'll put it down here. At x equals negative 2. And a local min of negative 41/27 at x equals 4/3. 23. Doing the same type of thing, but this time it's y equals the square root of x squared minus 1. Okay, so I'm going to get my table ready. I don't know what my critical values are yet, but that's okay. And let's take a derivative. So remember, this is the same as x. That's an equal sign. X squared minus 1 to the 1/2 power. That's what it means to be a square root, in exponential form anyway. And let's go ahead and do the chain rule, or chain rule. On that, we have to take the derivative of the inside. So the derivative of x squared minus 1 is a 2x. And then we have to do the derivative overall. So power rule, bring down the 1/2. So times 1/2. And then times the x squared minus 1. But now we have to subtract 1 from that exponent. 1/2 minus 1 is a negative 1/2. All right, and let's clean it up some. So I noticed that these 2's are going to cancel. And let's go ahead and set this equal to 0. And so I will have x in the numerator. This is going to go in the denominator because it has a negative exponent. I have to drop it like it's hot. And it's a square root. So square root of x squared minus 1. So x over the square root of x squared minus 1. Okay. I have a restriction in there because x squared minus 1 factors down to x plus 1, x minus 1. So that means that the restriction is x cannot equal 1 and x cannot equal negative 1, because 1 or negative 1 would make the denominator 0 if I plug that in for x. Okay, so we're restricted. This is where the derivative of y does not exist. Okay, but we can continue solving this, right, and see if we get any other critical values if we solve it, because I do have x in the numerator and the denominator this time. So let's get this out of the denominator. So I'm going to need to multiply by the square root of x squared minus 1, But whatever I do to one side, got to do to the other. These cancel, and I'll get 0 equals x. Oh, so I got another critical value. Okay, so I have so I have x equals 0, and I have x cannot equal 1 or negative 1. Okay, so here's a problem though. This is also where y prime does not exist. Because what if I plug in a 0 for x squared minus 1 there? 0 squared is 0. 0 minus 1 is a negative 1. We can't take the square root of a negative 1. So it also does not exist there. Okay? And we're going to take a look at the graph to see why. All right? So let's go ahead and go to our graphing calculator and see what is this graph doing. So we have the second square root, x squared minus 1 graph. It's got the mad eyebrows. Okay, so that's what's happening at x equals 0. It's not continuous. So there really is no max or min or whatever at 0. We only have something right here and right here. Well, since these go off to infinity, we're going to have no maximums. There's just a minimum here and a minimum here. And they're at the same height, which is 0. Okay, and we'll also show that by plugging it in. So we only have one at 1 and negative 1. Oops, put the negative 1 first since it's smaller. Okay, if you plug in a negative 1 for x, negative 1 squared is 1, 1 minus 1 is 0, square root of 0 is 0. If you plug in a 1, 1 squared is 1, 1 minus 1 is 0, square root of 0 is 0. So y has a minimum of 0 at x equals negative 1 and x equals positive 1. And let's also back up our answer by the picture of the graph, because we need to be in the habit of backing up our answer with as much information as we can. So there's negative 1, there's positive 1, and we know we've got the angry eyebrows there and there. Oops, my arrow's weird. It's not really higher on one side than the other. They're the same. It's symmetric, but my drawing is not reflecting that. All right, that was 23. Y equals 1 over the square root of 1 minus x squared. So this is the same as 1 minus x squared quantity to the negative 1/2, because it's a square root in the denominator, so it was dropped like it was hot, and it's a square root. So we need our t-chart, because we're going to need that in a little bit. And we're also going to need the derivative. Lipstick teaser. Right, mission? All right, so y prime equals, we have to take the derivative of the inside using chain rule, so that would be negative 2x times derivative overall, so we have to bring down that exponent, so negative 1/2, times stuff on the inside, but now it's the new power is negative 1/2 minus 1. So now negative 1/2 minus 1 is negative 3/2. Negative 1 1/2. All right, so let's clean this up a little bit. So those cancel, and a negative times negative is positive. So we will have 0 equals, because we said it equal to 0, remember? There's an x. Got to drop this like it's hot. It's a square root of 1 minus x quantity, or sorry, x squared quantity cubed, because it's to the 3rd power. Zoom in so you guys can see that a little bit better. Stop shaking. Okay. All right, so we have that. And I want to point out that we do have a restriction. X cannot be 1 or negative 1 again. One or negative 1. Let me zoom out a little bit. Okay. So that will make the denominator 0. So that means that the derivative does not exist at 1 or negative 1. Okay. I also want to point out that if we look at the original, the OG, that restriction applies right there too. Because we have x in the denominator, x cannot be 1 or -1 because it'll make the denominator 0. So that means that I cannot use 1 or -1 as a critical point because when I plug them in, it's going to be undefined in the OG, in the original. So those ones I'm not even going to use. All right, so let's continue on and solving this because I do have an x in the numerator, so I will be able to solve this and get an answer. So if I multiply by the square root of 1 minus x squared quantity cubed to both sides. 1. I don't know why I keep wanting to do that. Maybe because we normally have an x first, not the 1. Sorry, it's blurry, but when I move my hand, it's fine. Well, it doesn't matter. That's 0 anyway. And then these cancel, and we get x. So we get x equals 0. So there is our only critical value, and it's a 0. We like zeros. They're easy to plug in. All right, but before I do that, let's go ahead and do a number line. So it's 0. So remember, this has to do with the derivatives, the slopes, to know when they're positive, when they're negative. Okay, so if I plug in a -1 into this function, -1, I can't plug in. It's not allowed. So let's try like a -1/2. Okay, so if x is a -1/2, -1/2 squared is a positive 1/4. 1 plus a fourth is a positive number, but a negative divided by a positive is negative. And if I plug in a positive 1/2, because I'm not allowed to plug in a positive 1, positive 1/2, so positive half in the numerator, 1 minus a half squared is a fourth. So 1 minus a fourth is a 3/4, and that will be a positive number divided by a positive number, so this will be positive. Okay, so it's going from negative to positive. So that tells me that I have a minimum value when x is 0. Okay, so let's figure out, well, what is y when x is 0? So we have to go to the OG. So when x is 0, that would be 1 minus 0 is 1. Square root of 1 is 1. 1 over 1 is 1. So our answer is that y has a minimum of 1 at x equals 0. There we go. Number 27, y equals the square root of 3 plus 2x minus x squared. So I always like to rewrite that in exponential form because we're going to use power rule to take its derivative in a second here. So it's to the 1/2 power. All right, and we need our little t-chart ready to go. I don't know how many critical values it's going to have. We'll see. All right, let's take a derivative. Like, what color do I want to use? So the derivative would be, well, we have to take the derivative of the inside, chain rule. So that would be that's 0, that would be a 2, and a -2x in parentheses. And then derivative overall is the 1/2, because we have to use power rule. And then times the stuff on the inside. To the 1/2 minus 1 power is -1/2. Okay, and clean this up some. So these all have 2s. So we could take out this 2 with each of these. Those turn into 1s. So that would be, we'll just set it equal to 0 because we're going to have to do that anyway. 1 minus x times 1 doesn't do anything, times 3 plus 2x to the minus x squared to the -1/2 power. Okay, and I should have rewritten that. I should have dropped it like it's hot, and I didn't until after I was already writing it. So I was like, Okay. All right, so we do have x in the denominator. So I don't know what the restrictions are, but I don't think it's going to matter for this one. Actually, it is going to matter. So let's go ahead and take a look. We need to factor it. So 3 plus 2x minus x squared greater than or equal to 0. It has to be greater than or equal to 0. If it's negative, then I can't do it. Okay. also, and that's for here. And then here it has to be strictly greater than 0. So let's put greater than 0. All right. So let me see. I want to flip this around. Negative x squared plus 2x plus 3. Just put equals 0. And just to find the critical points there. All right. So I want to factor out that negative 1. Nobody likes that negative out front. And let's see. So I have minus 3 plus 1, right? So x equals 3 and x equals negative 1 are my points of x that would make the denominator 0. Okay, so these are the restrictions. So restrictions, x cannot equal 3, x cannot equal negative 1, because that will make the denominator 0. Okay, so, but those are also our critical values for the graph, negative 1 and 3. And we can continue solving this. So let's just, instead of writing it, because I don't want to write it, if we were to multiply the square root of 3 plus 2x minus x squared to both sides, it would cancel out, and we would get 0 equals 1 minus x. Add the x to the other side, and x equals 1. Okay, so we have 3 critical values that we could try. So list them in order from smallest to biggest. So we have negative 1, 1, and 3 to try out. Okay, and let's go ahead and do our number line sign chart, little graph here, y prime, and I need negative 1, 1, 3. So if I plug in something smaller than negative 1, like a negative 2, and when I plug it in, I plug it into the derivative. See, 1 minus a negative 2 would turn into a 1 plus 2, so it's positive in the numerator. And let's see, if I do a negative 2 times 2, that's negative 4. 3 minus 4 is negative 1. Negative 2 squared is 4. And then negative 1 minus 4, that's a negative number, so I can't plug that in over there. Okay, so I'm stuck. All right, so let's find a number between negative 1 and 1, and like a 0. Zeros are easy, so I have a positive 1. Those will wipe out over the square root of 3, so that'll be positive. Okay, and if we plug in a 1, or something between 1 and 3, like a 2. 1 minus 2, that's a negative 1. 2 times 2 is 4. 4 plus 3 is 7. 2 squared is 4. 7 minus 4 is 3. So that is, sorry, 1 minus 2. That would be negative over a positive, so that's negative. Sorry, I had a little brain fart for a second there. All right, so that means at 1, it goes from positive to negative. So I have a max. Okay. And so I want to know what's going on with the negative 1 and the 3. Why am I not able to plug those in? Why am I having trouble? What does this look like? So we're going to draw a picture of the graph, and we're going to get it from our graphing calculator. Because we're learning. We're trying to figure these out. So we need to understand the behavior, understand what they look like. And sometimes we need to go to a calculator to do that. Okay, so this is the square root of 3 plus 2x minus x squared. And what's my window? Let's go from negative 10 to 10. I might have to zoom in, but we'll see. Oh, okay. So from negative 1 to 3, it's doing this. All right, let's change the window. Let's go from negative 1 to 3. Let's get a closer snapshot of this. Oh, it does that vertical tangent thing. So it comes down and it's like flat on the sides. Okay, so at negative 1 and positive 3, it's doing this thing, where it's kind of flat on the sides. All right, that's why it's undefined at negative 1 and positive 3, okay? And it really only has one max, and that is at an x value of 1. Okay, so now that makes sense. And that's why when I plugged in a negative 2, it didn't work, and why when I go higher than 3, it doesn't work. So if I go to here, I only care about 1. So if I plug in a 1 into the OG, 2 times 1 is 2. 2 plus 3 is 5. 5 minus 1 is 4. Square root of 4 is 2. So y has a max of 2 at x equals 1 and oh, you know what? These are minimums though. I was like, why do I have and written on my notes? But we do have minimums, so I do need to find those too. These are minimums. So if I plug in a -1, let's see, that would be a -2. 3 minus 2 is 1. 1 minus 1 is 0. Square root of 0 is 0. Plug in a 3. Well, hey, aren't these the places where that makes this equal to 0? So if I plug in a 3, it's also going to be 0. Plus, we can see on the graph, -1, 0, 3, 0. Okay, so and a minimum of 0 at x equals -1 and x equals 3. So the hard part about these guys is sometimes when we get stuck, we have to remember, okay, there's another way. Let's look at the graph. Let's graph it in our graphing calculator and see what's going on and then go from there. Okay, whenever you're getting stuck algebraically, it's homework. So you can always refer to your graphing calculator. It has a logical order about things. Okay, number 29. I have all these ready this time, and I think this is flowing so much faster for me. This video better work. That's all I gotta say. All right, number 29, y equals x over x squared plus 1. Let's get our table of values ready. I don't know what's going to be in it. And let's do the derivative. Okay. So we have x over x squared plus 1. So when we do the derivative, we got to use quotient rule. So low d high minus high d low over low squared. So the low is x squared plus 1 times the derivative of the high is 1. Derivative of x is 1. Minus the high times derivative of the low. Derivative of x squared plus 1 is a 2x all over low squared. Okay, let's clean this up some more. So that's just x squared plus 1 minus 2x squared over x squared plus 1 squared. So 1x squared minus 2x squared is a -x squared plus 1 over x squared plus 1 squared. It always bothers me when it's so close, but I can't cancel anything out because even if I factor out a -1, it'll change this to a -1, but that one's a +1. I'm like, it's so close. Okay, well, let's set this equal to 0 and solve. I'll just put equals 0 right here. All right, now this doesn't have any restrictions on x because when we plug in any number for x and we square it, it's going to be a positive number, and a positive number plus 1 will still be a positive number. It will never, ever, ever equal 0. So I don't have any restrictions there. So if I multiply that to the other side, anything times 0 is 0. I will have -x squared plus 1 equals 0. Subtract the 1. Divide by that -1. And then square root it. So whenever we take a square root and we're solving for a variable, we get plus or minus whatever that square root is, and square root of 1 is 1. So I have x equals +1 and -1. So I only have 2 critical values to try here. So positive or -1 and a +1. Always put the smaller one first. Okay, and let's do a little number line graph of our derivatives of the slopes. So -1, +1. All right, if I pick something smaller than -1, like a -2, and plug that in up here, -2 squared is 4 with a minus out front. So -4 plus 1 is a negative. So it's negative in the numerator. And then it'll be positive in the denominator because -2 squared is 4. 4 plus 1 is 5. 5 squared is 25. So negative over positive is negative. Something between -1 and 1 would be 0. So if I plug in zeros for the x's, I will have 1 over 1, which is a positive slope. And then if I plug in something bigger than 1, like a 2, 2 squared is 4, but there's a negative out front. -4 plus 1 is -3. So I have a negative in the numerator. And 2 squared is 4, 4 plus 1 is 5. It's going to be a positive in the denominator. So negative over a positive is negative. So that means I have a minimum here and positive to negative, so maximum here. So I have a min and a max. Okay, what are those mins and maxes? So, or min and max. So we got to plug them into the OG. You guys getting the hang of these? It's all the same steps. So plug in a -1 for x. So we have a -1 over -1 squared is 1. 1 plus 1 is 2, so it's a -1/2. And then if I plug in a 1, 1 over 1 plus 1 is a positive 1/2. Okay, so we can say y has a min of -1/2 at x equals -1 and a max of positive 1/2 at x equals positive 1. All right, out of the odds, we're on to 39. So number 39, the directions say, where are the directions? It says, identify the critical point and determine the local extreme values. Okay, so these look harder than they are. All right, so let's find, we're gonna need a t-chart. Always need that. We're gonna need to do the derivative, so we'll do that. We'll do that soon, but let's go ahead and graph what this looks like. So I'm gonna use a different color for that. Let's graph it. One, two, three, four. All right, so this one is 4 minus 2x, and x has to be less than or equal to 1, so it can equal the 1. So let's start with the 1. If I plug in a 1, 4 minus 2 times 1, so 4 minus 2 is 2. So 1, 2. And then plug in a 0, because that's less than 1. And we get 4, 0, 4. And then it would just keep going forever, because it's all values of x are less than or equal to 1. So to show it goes on forever, you draw an arrow. Okay. For the other side, plugging in a 1, but it's an open point there. 1 plus 1 is 2, so 1, 2, so it's open there. And then we have to go greater than 1. So plug in a 2, 2 plus 1 is 3, so 0.2, 3. If I plug in another one, plug in a 3, 3 plus 1 is 4, so 3, 4. And it goes on forever. Okay, so there's my graph. Obviously, we have a corner there, so we know its derivative won't exist at x equals 1. Okay, and that is actually a critical point, which we know that where a derivative does not exist could be a max or a min, and we could tell that that is a minimum there. Okay. Also, if we were to take the derivative, which is what we're going to do next, so the derivative of 4 minus 2x would be a -2. The derivative of x plus 1 will be a 1. And obviously, if we were to set these equal, they're not the same thing. So even by doing that, it shows since the derivatives don't equal each other, it's not differentiable at x equals 1. And we see that algebraically, and we also saw it on the graph. Okay. So there's only one critical value, and that is at x equals 1. So when we plug that into the OG, we plug it in where we are allowed to, where we can equal 1. We can't equal 1 here. It's got to be greater than 1. But we can be less than or equal to 1 here. So we're going to plug it into the 4 minus 2x, and 4 minus 2 times 1 is 2. So we can say that y has a min of 2 at x equals 1. And that's it for number 39. Number 40. We have y equals 3 minus x, where x is less than 0, and 3 plus 2x minus x squared, where x is greater than or equal to 0. So obviously for number 40, we know that we have a critical point at x equals 0. Let's go ahead and start with the graph this time. Okay, so at 3 minus x, x is less than 0. If I were to plug in a 0 for x, I would get 3. So 0, 3, but it's an open point. Okay, and then a number less than 0, negative 1. If I plug in a negative 1, 3 minus a negative 1 will be 3 plus 1, which would be a 4. So this one's going to infinity, negative infinity. Numbers less than 0. All right, for this one, this is a parabola. And we're picking numbers greater than or equal to 0. So we can equal 0. So let's start with 0. Plugging in a 0. Wipe out 3. So 0, 3. So it is defined at x equals 0 because we fill in that point with this second piece of this piecewise function. Plug in a 1. 3 plus 2 times 1 is 2. So that's 5 minus 1 squared. So 5 minus 1 is 4. So 1, 4. 1, 1, 2, 3. 4. Plug in a 2. 2 squared is 4, so negative 4. 2 times 2 is 4. 4 minus 4 is 0, so it's 3. So 2, 3. Okay, so I know that because this is an x squared that it's a parabola. So there it is. There's a vertex. Looks like that. I don't know why I'm having trouble with my arrows today. All right, so we got the picture of our graph. We see a corner, so we know it's not differentiable there, but it is continuous, okay? And yeah, and we see, I don't know about you, but I can see a max and a min. I see one max and one min. All right, so let's show it algebraically. So y prime, derivative of 3 minus x is a negative 1. The derivative of 3 is 0. 2x would be a 2. Negative x squared would be a negative 2x. And let's set these equal to each other. Remember, we have to plug in the 0 for x. So that wipes out, but negative 1 does not equal 2. So this shows that it's not differentiable there. But we knew that it wasn't differentiable at x equals 0, because at x equals 0, there is a corner. So that's why. Okay. So we know that negative 1 does not equal 2, but we do know, if we take these each separately, negative 1 does not equal 0, obviously. So that one's thrown out. Take this one. 2 minus the other part of the derivative, 2 minus 2x, set that equal to 0. Add 2x to both sides. And divide by 2. This is how we get the critical point x equals 1. And we know that at x equals 1, that's a maximum. Right? And we know that at x equals negative 1, that's a minimum. Okay, so we have two values to try here on our table, which I didn't draw yet this time. So I need a 0 and a 1. And remember, that goes to the OG, where we are allowed to plug it in. Okay, so this interval says x less than 0, so I can't plug in the 0 here. But this says x greater than or equal to 0, so I am allowed to plug in the 0 here. So that wipes out, so I get left with a 3. Okay, and look at that. 0, 3, that's my minimum. Plug in a 1, and I'm allowed to plug in a 1 when x is greater than or equal to 1, because it's not less than 0. So 3 plus 2 is 5. 5 minus 1 is a 4. Okay, so I have my max and my min. And I can see it from the graph, but you should also have the habit of drawing the number line and showing the positives and negatives. Okay, so we know that To the left of 0, that's a negative slope. Between 0 and 1, that is a positive slope. After 1, it's a negative slope. So negative to positive, positive to negative, we have our min, we have our max. Min, max, min, max. Okay, so let's write our answer. We can say, I'll put it over here, y has a minimum of 3 at x equals 0 and a max of 4 at x equals 1. Okay, so all these steps, I know a lot of them seem kind of redundant. If we know what it is on the graph, why do we have to do it algebraically? And that's all for justification purposes. You really need to be in the habit of finding multiple ways to arrive at the same answer, because sometimes you'll be allowed to use a graphing calculator, sometimes you won't. So sometimes you have to graph it by hand, sometimes you won't, sometimes you have to strictly do the algebra by hand, sometimes you can rely on the graphing calculator. You have to be prepared for it all. All right, number 41. We have this piecewise function, and I'm not going to graph it this time. We're going to try not to, okay? So let's start with the derivative. So the derivative would be negative 2x minus 2 on x less than or equal to 1. And for the second piece, negative 2x plus 6 on the interval x greater than 1. Okay. So what we can do to find the critical points is set each of those derivative pieces equal to 0. So I'd add 2 and then divide by negative 2, so I would get that x equals negative 1. There's 1. And for this one, take the negative 2x plus 6, set it equal to 0. I would subtract 6 and then divide by negative 2, so x would equal a positive 3. Okay. Also, I need to check for differentiability, because we know if the derivative does not exist at x equals 1, then that's also a critical point that we need to include. Okay, so let's set these equal. Negative 2x minus 2, is that going to equal negative 2x plus 6? And we need to plug in a 1 for the x. So negative 2 times 1 minus 2, is that going to equal negative 2 times 1 plus 6? So that'll be negative 4. Negative 2 plus 6, positive 4. Negative 4 does not equal positive 4. So it's not differentiable at x equals 1. So it is a critical value that we must try. All right. So again, I forgot to start with my table. That's okay. I know that I need it. So it would go negative 1, 1, and then 3. And let's do a number line graph of our derivative. So I need negative 1, positive 1, and 3. All right, so to the left of negative 1, if I plug in a negative 2 into the derivative, so I'm allowed to plug in numbers less than or equal to 1 here, only greater than 1 here, so I can plug in a negative 2 right there. Negative 2 times negative 2 is positive 4. 4 minus 2 is 2, so it's positive. If I plug in something between negative 1 and 1 will be a 0. I can plug in 0 in the first one. It's in that interval, x less than or equal to 1. So it would be a negative 2, so negative. Between 1 and 3 would be a 2. I can plug in a 2 right here because x can be greater than 1, and 2 is greater than 1. So negative 2 times 2 is negative 4. Negative 4 plus 6 is 2, so it's positive. And then if I plug in a number bigger than 3, like a 4, again, I'm in that second interval, x greater than 1, so 4 would be in that interval. Negative 2 times 4 is negative 8. Negative 8 plus 6 is a negative 2, so it's negative. So from positive to negative, I'm going to have a max. Negative to positive, min. Positive to negative, max. Max, min, max. Okay, so I have a maximum at negative 1 and a maximum at 3 and a minimum at 1. Okay, All right, let's find out what those y values are and what those actual max and mins are. So because these are polynomials, and we have to plug these into the OG, remember? I want to use synthetic division. It's just way easier. So I'm going to try -1 first. And I'm allowed to plug in a -1 when x is less than or equal to 1. So for this one. So -1, -2, 4. Multiply. Add. Multiply again. I get 5. So -1, 5. Let's try a +1. And we could plug in a +1, x less than or equal to -1, so same one. -1, -2, 4. Multiply, add, multiply again, add, get a 1. So 1, 1, and then a 3. Now 3, I can plug into the second piece because x is greater than 1, 3 is greater than 1. So, oops, up here, the original. So I -1, 6, -4. That's what you have to be careful of. You have to really pay attention to details here. 9, 5. 5, 1, 5. Okay, so we know what they are now, and so now we can say our answer. What color? Oops, I keep knocking this. So I can say that y has a minimum, because there's only one minimum there, of 1 at x equals 1, and a max of 5, because they're both 5, at x equals -1, and x equals 3. And that's 41. Y equals -1/4 x squared minus 1/2 x plus 15/4, where x is less than or equal to 1, and x cubed minus 6x squared plus 8x, where x is greater than 1. All right, so let's just start with a derivative. Obviously, it doesn't matter where you start here. You know what you need to be doing. So, power rule. That would be 2 times -1/4. That would be -2/4, so that reduces to -1/2 x minus 1/2, where x is less than or equal to 1. All right, and then this one would be 3x squared minus 12x plus 8, where x is greater than 1. Okay, let's set each of those equal to 0 and find some zeros, find some critical points. So -1/2 x minus 1/2 equals 0. If I add 1/2 to both sides and then divide by -1/2, a half divided by -1/2 is -1. So x equals -1. So there's a critical point. And then for this one, I would have 3x squared minus 12x plus 8 equals 0. And if I try to use product sum, let's see, 3 times 8 is 24 and adds up to -12. I can do 8 times 3, but that one has to be positive, or they both have to be positive, or both negative to add up to -12. 8 and 3 is 11. 6 and 4 is 10. 2 and 12 would be 14. It's not factorable. So we have to find the zeros with a calculator. So let's see. 3x squared minus 12x plus 8. Let me change my window. Let's go from -1 to 4, since it looked like it was close there. This is a parabola. This derivative function's parabola. Okay, so the zeros would be here and here. So I want to trace, scooch this up because we go from left to right. So I want it to be positive, but the positive number right before it turns negative. And I want to hit second calc, need 2 for 0. Left bound is good. Scooch it over till it's negative, the y value is negative, hit enter, guess, and it's 0. At y equals 0, it's 0.845, so 0.85. So x is approximately 0.85, and there was another place where it crossed the x-axis at, so trace, scooch it over until we get to the negative value that's right before it turns positive, so this one, and hit second calc, 0, enter, right bound, scooch it over till it's positive, enter, guess. 3.15. Isn't it so nice? You don't even have to use the quadratic formula. You can just use your graphing calculator. But if you didn't have your graphing calculator, you would use the quadratic formula on that. All right, so we have these two critical values as well. And now we need to also check, is it differentiable here? So we need to check these things. Okay, so I need to set these equal to each other. Let me use a different color though. So -1/2 x minus 1/2, is that going to be equal to 3x squared minus 12x plus 8? And since it's at x equals 1, we have to plug in a 1 for x. So -1/2 times 1 is just -1/2. -1/2 minus half is -2/2, so that's -1. 3 times -1 squared, 1. 3 times 1 squared would be 3. 3 minus 12 is -9. -9 plus 8 is a -1. So it is differentiable at x equals 1. All right, so let's do a number line graph and see what happens with our signs. Let's see, the lowest I have is -1, and then 0.85, and then +1, and then positive 3.15. Okay, so let's look at what these signs are. So if I plug in a -2 into the derivative, I'm allowed to plug in a -2 on this interval because it's less than or equal to 1. So -1/2 times -2 would be a +1. 1 minus 1/2 is positive, so this is positive. Between -1 and 0.85, we could try a 0, and 0 would be x less than or equal to 1, so that would just be a -1/2, that's negative. Between 0.85 and 1, well, let's pick like 0.9. 0.9 is less than or equal to 1, so we could plug that in here. So -0.5 times 0.9, and then minus 0.5, it's a negative number. So it's negative again. Huh, what does that mean? And then between 1 and 3, we could plug in like a 2. And 2, we're allowed to plug in on this interval because x is greater than 1 there. So 2 squared is 4. 4 times 3 is 12. 12 minus 12 times 2 is 24. So 12 minus 24 is -12. -12 plus 8 is a -4. So it's negative again. And then 3.15, something bigger than that, like a 4. You could plug in a 4 in that interval because 4 is greater than 1. 4 squared is 16. 16 times 3, I have my calculator here, is 48. Minus 12 times 3 is 36. Oh, sorry, 12 times 4 is 48. So it's 0 and then 8. So it's positive. Okay. All right. So what does this mean? Well, from positive to negative, goes up and then down. So we have a max. but then it goes down and down and down, so it's still negative, and then it goes from negative to positive. So we have a min. Okay, so we only have a max and a min. So all these other points is just this, the slope is still the same. There's no sign change, so there's no waves. It's not creating any waves. So when we do our little t-chart, I don't care about the other points. I just need -1 and 3.15 because that's my max and min. So if I plug in a -1, and remember we plug that into the OG, the original, -1 can be allowed to plug in here because x is less than or equal to 1. So -1 squared is 1, so that'll be -1/4. And then -1/2 times -1 will be a +1/2 plus 15/4. So -4 plus 1/2 is a +4. 1/4 plus 15/4 is 16/4. 16 divided by 4 is 4. Okay. All right, and then for this one, 3.15, I'm going to use my calculator for that. 3.15 fits in the interval x greater than 1. So I'm just going to type in 3.15. Oops, I got to clear it. 3.15 cubed minus 6 times, oops, shoot, cubed. Got to drop the arrow down. Then minus 6 times 3.15 squared plus 8 times 3.15. And I get negative 3.08. Okay, so I can say y has a max of 4 at x equals -1 and a min of -3.08 at x equals 3.15. And that's it.